Welcome back to the Deep Dive. We are undertaking one of the most comprehensive deep dives we have ever attempted today, I think, focusing on the man whose name is literally, well, a synonym for brilliant, Albert Einstein.
It really is. And it's easy to look at that iconic image, the wild hair, the sweater, and kind of forget that the path he took, well, it wasn't straightforward at all. Becoming the architect of the 20th century's biggest intellectual revolution, it was profoundly unconventional.
Yeah.
Our sources, the ones shared by you, our listener, they paint this picture of someone restless, self-taught, often stateless, actually. And his greatest work, it wasn't dreamt up in some fancy academic lab.
Yeah.
It came while he was struggling to make ends meet out of patents.
That's exactly right. And our mission today really is to dig into those formative experiences, his personal philosophy, and those crucial moments of struggle that underpinned his genius. We're tracing the whole arc from that tumultuous German childhood to the absolute explosion of the Annus Mirabilis in Bern, then his sudden global fame, and even the really painful moral conflict he wrestled with later on, when his abstract ideas led eventually to the atomic bomb.
And we promise we won't leave the physics totally abstract. We're going to try and connect his most fundamental, really mind-bending concepts like, the warping of space-time, the nature of light, to the practical stuff, the technologies you rely on every single day, maybe without even thinking about it, opening an automatic door or using your phone's GPS.
Exactly. Okay, let's unpack this journey, starting right at the beginning. German Empire, March 14, 1870. The sources point to a family environment that was, it was defined by intelligence. Definitely ambition, but also.
Yeah, constant financial uncertainty. It sounds like that really dictated almost everything. His father, Hermann Einstein, he came from an academically gifted family, Ashkenaz heritage, apparently quite strong in applied math himself.
Oh, interesting.
But he was kind of forced into business instead of academia because the family just didn't have the money. So he partnered with his brother, Jacob, and they set up Einstein & Co., electrical engineering company.
Right at the dawn of electrification in Central Europe. They moved pretty quickly to Munich in 1880. He started school first in a Catholic elementary school, then the Leopold Gymnasium in 87. You can kind of see the father's practical engineering focus maybe shaping things, but it clearly didn't quite fit young.
No, it really didn't seem to. The family's whole livelihood was tied up in the success of Einstein & Co. And when the company failed to get this really vital Munich electrification contract in 1894, the family was uprooted again. Moved to Milan, then Pavia in Italy. And this constant instability, it must have had a huge effect on...
You'd think so. And it's during this really turbulent early time that we see the first undeniable proof of his own intellectual drive, right? His self-directed power.
Absolutely. The sources talk about him teaching himself algebra and advanced geometry.
By age 12.
Yeah. By age 12 in 1891, mastering Euclid on his own. I mean, that level of self-teach, it's incredibly rare.
It really is.
It suggests his mind was already working on these foundational abstract principles, right from the start. And there's that story about his tutor, Max Talmud.
Oh, yeah. Tell us about that.
Well, Talmud was an optometry student, I think, tutoring him in advanced science and math. But he apparently realized very quickly that his student was just outcasing him.
Wow.
Yeah, Einstein was already grappling with calculus, advanced geometry, way beyond what Talmud was supposed to be teaching.
And this is where it gets really interesting, I think, moving beyond just the math into philosophy, because that seems to have shaped his whole approach to physics later on.
Totally. By age 14, he wasn't just solving equations. He was diving into the really dense philosophical work of the German Enlightenment, Immanuel Kant.
Kant, at 14, we're talking critique of pure reason kind of Kant.
Exactly. Critique of pure reason, which is, arguably one of the most challenging texts in metaphysics out there. It deals with incredibly complex ideas like transcendental idealism, the limits of human understanding.
Yeah.
And the fact that a 14-year-old was not just reading it, but apparently grasping the core concepts clearly enough that it, quote, bewildered his tutor. It just shows he wasn't just a calculator, right? He was fundamentally asking, how do we know what we know? Pretty much the exact question general relativity tries to answer later.
Okay, so his mind's already on this really abstract level, which must have clashed terribly with the school environment, the gymnasium, the rote learning.
Oh, absolutely. He hated it, hated the strictness, the memorization. He eventually left Munich to join his parents in Italy. But this period of upheaval, it also led to a really defining political choice for him.
Which was?
He renounced his German citizenship.
Really? Why?
Specifically to avoid the mandatory military service that Germany required back then. It wasn't a small thing to do. It was a pretty profound anti-authoritarian statement.
So he became stateless.
Yeah, for about half a decade. Just stateless, an international nomad, you could say. Politically unattached, just focused purely on getting his scientific.
Wow. Okay. So he tries to get into the Swiss Federal Polytechnic School in Zurich. He's 16, scores high technically, but too young.
Too young for immediate admission, yeah. So he spends another year preparing, passes the Swiss Matura equivalency exam, and finally gets into the Polytechnic in 1896. He's 17. He was clearly looking for that intellectual freedom, and Switzerland seemed to offer it.
And those Zurich years, they were pretty transformative, right?
Hugely transformative. His research interests immediately zeroed in on the two areas he'd eventually revolutionized: quantum mechanics and the nature of light. He was looking for ways to measure molecules accurately, but his real obsession, it seems, was light.
And the view back then was?
Almost universally accepted. Light behaves exclusively as a wave. But Einstein, he was already questioning that, already poking holes in that certainty.
This is also where his personal life, complicated.
Very complicated. He meets Mileva Merrick, Serbian, a mathematician and physicist herself, and notably one of only 2 women in his program at the Poly.
They connected intellectually then.
Deeply. They bonded over shared interest. But yeah, the sources confirm their relationship faced massive social hurdle. It's widely thought Mileva contributed to his research.
Right, given their studies together.
Exact. Though, the exact extent, how much she contributed, that's still unclear, still debated by historians. What is certain is the scandal.
The pregnancy.
Yeah. In 1901, she became pregnant. A child out of wedlock back then was, it was a huge social, especially for someone trying to build an academic career.
So what happened?
Mileva went back to Serbia to give birth to their daughter Lyserl, and Lyserl's fate, it's just tragic. And a bit of a mystery.
Yeah.
She either died young, maybe scarlet fever in 1903, or perhaps put up for adoption in Serbia. We don't really know for sure.
That's heartbreaking. What a difficult start.
A very difficult start to their family life. They did get married, eventually, in January 9, and later had 2 sons, Hans Albert and Eduard. But before that marriage, even after finishing his diploma in 1900, Einstein struggled professionally for like a year.
It's kind of one of history's great ironies, isn't it? The guy who'd reshaped physics couldn't even get a basic teaching.
It really is. He finally got Swiss citizenship in 1901, which ended those 5 years. And then, through a family friend, Max Gross, he landed a position.
Not in academia.
No, not at all. At the Swiss Patent Office in Bern.
As a patent examiner.
A patent assistant examiner, yeah. Think about that environment for a second. Not high-tech university labs or lecture hall. He's sitting at a desk reviewing diagrams, specifications for inventions.
Stuff submitted by Swiss entrepreneurs, mechanical things, electrical things.
Exactly. This is what we call the patent office crucible. And it's such a crucial detail, often just glossed over. This job wasn't just a paycheck. It was applied physics grad. Precisely. His job was to constantly assess if these devices, these inventions involving electrical conduction, synchronizing clocks, telecommunication stuff, if they were viable, if they were new. He was literally seeing dozens and dozens of attempts by people to fix the problems they saw in 19th century classical physics, especially electromagnetism.
So he's seeing day in, day out where the existing theories just weren't cutting it, where they broke down in practice.
Exactly. It forced him to confront on a practical daily basis the limitation. He was perfectly positioned, maybe uniquely positioned, to see that all these little fixes, these complicated gadgets, they were just Band-Aids.
Right.
They were patching over a much deeper theoretical hole, a hole that could only really be filled by completely rethinking reality itself.
Wow. So the office gave him stability for his young family.
Yeah, and anonymity from the academic world he was still trying to break into. And critically, that exposure to the exact real-world problems his theoretical work on light and electromagnetism was about to solve. While he was stamping patents, he was also working part-time on his PhD thesis and writing these papers for the Annalen Physics.
And what came out of that Bern office in 1905, it's still just astonishing, isn't it? One of the most incredible bursts of creativity in human
without a doubt. Let's talk about the Annus Mirabilis, the miracle year.
Okay.
So in that single calendar year, 1905, remember, while working full-time at the patent office. Full-time. Einstein publishes 4 separate research papers. Each one on its own would have cemented his place in science history. But together, they just revolutionized everything. Our entire understanding of existence, from atoms right up to the fabric of space-time.
Okay, let's break them down. Paper number 1, June 9th, The Photoelectric Effect. The title was On a Heuristic Viewpoint Concerning the Production and Transformation of Light. Catch?
Yeah, not exactly pop science type, but this was radical. It explained that phenomenon where if you shine light on certain metals, electrons pop.
Right.
But to explain why it happened, Einstein had to challenge that almost universally accepted wave theory of light. He proposed that light energy doesn't travel like wave. Instead, it travels in these tiny, discrete, quantized packets of energy. He called them finite number of energy quanta. We now call them photons.
Okay, so light is like little bullets, almost.
Kind of, yeah. These photons, They move without dividing up, and they can only be absorbed or generated as whole units. And this explained why only light of a certain frequency could knock an electron loose, no matter how bright the light was.
Because you needed one photon with enough individual energy.
Exactly. You needed a single photon with sufficient punch. And this wasn't just some abstract idea. This is the specific discovery they cited when he won the Nobel Prize for Physics later on.
And the practical uses are
everywhere. Think about automatic door, the sensor that keeps it closed. There's a beam of light, a stream of photons hitting it. You walk through, you block the beam.
The sensor stops getting photons.
Right. And that signals the door mechanism to open. That basic concept is behind countless sensors, solar-powered calculators, the light sensors in digital cameras. It's foundational.
Okay, incredible. Then, just 6 weeks later, July 18th, paper 2. This one basically proves atoms and molecules are real on the motion of small particles suspended in a stationary liquid.
Yeah, for centuries, atoms and molecules were mostly theoretical, based on how chemicals combined, like John Dalton's work. But there wasn't a really solid, reliable way to measure them or prove they were actual, tangible things.
So how did Einstein do it?
He analyzed Brownian motion, that seemingly random jiggling you see when tiny particles, like pollen grains, are suspended in water.
I've seen that under a microscope. It looks random.
It looks random, but Einstein showed it wasn't random at all. It was caused by the constant, invisible bombardment of those particles by the much smaller, unseen...
The water molecules are hitting the pollen.
Constantly, yeah. Violent, that scale. His paper showed how you could use the measurable movement of the bigger, visible particles to calculate the size and number of the tiny, visible molecule hitting.
Wow.
This work, especially after Jean Perrin experimentally confirmed it in 1908, it just unequivocally proved that atoms and molecules were real. They were the actual building block. It became the bedrock of 20th century.
Okay, 2 down. Then come the real heavy hit.
Yep.
September 26, paper 3. On the electrodynamics of moving bodies gives us special...
Right. The main goal here was to sort out the inconsistencies between Maxwell's equations for electricity and magnetism and Newton's classical laws of mechanics, especially when things start moving really, really fast, like near the speed.
And the core idea is...
It rests on 2 main postulates. First, the laws of physics are the same for all observers who aren't accelerating. Second, and this is the big one, the speed of light in a vacuum...
Constant for everyone. It doesn't matter if you're moving towards the light source or away from it.
Exactly. The measured speed of light is always the same. This completely broke with Newton. Newton assumed speeds would add up, If you're running towards a thrown ball, it seems to come at you faster. Light doesn't do that.
Which leads to those really weird consequences for time and space.
Mind-bending consequences. If the speed of light has to be constant for everyone, then something else has to give when you're moving very fast. And that something else is time and space themselves.
We have to warp, contract.
Yeah, time dilation and length contract. Time actually slows down for a moving observer relative to a stationary, and distances appear to shrink in the direction of motion. There's that classic anecdote, maybe apocryphal, about the streetcar in Bern. He imagined the streetcar accelerating close to the speed of light. Looking back at the town clock tower, its arms would appear to freeze from his perspective.
Because the light signals couldn't catch up properly.
Sort of, but the clock inside the streetcar with him, that would tick along perfectly normally. His point was that the experience of movement, space, and time, it's all relative to the observer's frame of reference.
And this abstract thought experiment, it has real-world tech applications like GPS.
Absolutely crucial for GPS. This is where the physics literally comes down to Earth, into your pocket.
How does that work?
Okay, so GPS relies on this network of satellites orbiting Earth, right? They're moving really fast, about 14,000 kilometers per hour.
Okay.
That speed is fast enough that, according to special relativity, time for the clocks on those satellites actually runs slightly slower than clocks down here on Earth.
Just a tiny bit slower.
Tiny, but measurable and critical. If the GPS receivers in your phone or car didn't constantly apply a correction based on Einstein's special relativity,
the calculated position would be off.
It would drift by several kilometers every single day. So yeah, when you fire up Google Maps or whatever you use, you are directly relying on Einstein's 1905 paper to find your way.
That is amazing. Okay. One more paper from the miracle, November 21st. Does the inertia of a body depend upon its energy content? This one gives us the big one.
The big one. EMEM-CIO.
Energy equals mass times the speed of light squared.
Exact. Mass-energy equivalent. It fundamentally showed that mass and energy are, well, they're 2 sides of the same coin. They're interchangeable. And that's C. the speed of light. That's a colossal number.
And c squared is astronomical.
Absolutely astronomical, which means that even a tiny amount of mass contains a truly enormous amount of locked-up energy. He called it rest energy.
So if you could somehow unlock that energy.
Precisely. If you could disturb the nucleus of an atom, say through nuclear fission, you could release a staggering amount of energy, light, and heat from a minuscule amount of matter. This paper provided the fundamental theoretical basis for how nuclear power plants work.
Generating huge amounts of energy from small amounts of fuel.
Exactly. But, and this is the foreshadowing, this beautiful, simple EMC hot, this theoretical, it would later become the source of immense moral anguish for Einstein himself.
Right. We'll definitely come back to that. So the Annus Mirabilis, 1905, it just catapults him out of the patent office, doesn't it?
Completely launches his career. He finally leaves the patent office in 1908, gets a teaching post at the University of Bern, and then the ascent is just incredibly fast.
Where did he go from Bern?
Within just a few years, University of Zurich in 1909. Then he moves to the German-speaking part of Charles Ferdinand University in Prague in 1911. He had to acquire Austrian citizenship for that post. Then he gets pulled back to his alma mater, the Zurich Polytechnic, in 1912, clearly.
And the absolute peak, academically at least, comes in 1914 with the...
Yeah, hugely prestigious offer, really pushed by the scientific giants of the time, Max Planck and Wolf. They convinced him to take a post at the University of Berlin.
And it came with perks.
Big perks. Automatic membership in the elite Prussian Academy of Sciences, and he became the director of the newly formed Kaiser Wilhelm Institute for Physics, top of the academic world.
But this big move, it caused personal problems with Mileva.
Yeah, significant turmoil, it seemed. The pressures of this high-stakes academic life in Berlin, combined with, well, the sources indicate Albert was growing closer to his cousin, Elsa Lowenthal. It led Mileva to return to Zurich with their two sons, Hans Albert and Eduard. They eventually divorced in 1919, and Einstein married Elsa shortly after.
And his arrival in Berlin, this big career moment, it gets immediately overshadowed by world events, right?
Immediately. Summer 1914, World War I breaks out, just as he's settling in. And this forces the scientist to really confront his political and moral beliefs head on.
Because he was a pacifist.
A deeply committed, lifelong pacifist. But Germany was gripped by this intense patriotic fever. Dozens of prominent German scientists and intellectuals signed this document called the Manifesto of the 93, which basically endorsed Germany's war aim.
And Einstein.
He flatly refused to sign it, just wouldn't do it.
What did he do instead?
He chose a completely different path. He actually co-authored a counter-manifesto, the Manifesto to the Europeans. It argued that Europe shared this common culture and that scientists and intellectuals should use that connection to try and end the war quickly.
That must have taken some courage in wartime Berlin.
Absolutely. It was a very courageous stance against the tide of nationalism, and it really set the stage for his decades of political advocacy later in life. He wasn't afraid to speak out.
And somehow, amidst all this wartime chaos and personal upheaval, he's also doing his most profound scientific work since 1905.
It's incredible. He's laser focused on expanding his 1905 theory of special relativity to include gravity and acceleration. And this becomes his absolute master, the theory of general relativity, which he finalized between 19 and...
Okay, explain general relativity again. It's not gravity as a force.
Right. Forget Newton's idea of gravity as some mysterious force pulling objects together across empty space. Einstein showed that what we perceive as gravitational attract-two masses, say, the Earth and the Sun, is actually the result of those masses warping or curving the very fabric of space-time around them.
Okay, the classic analogy is the bowling ball on the rubber sheet.
Exactly. Put a heavy bowling ball on a stretched rubber sheet. The sheet dips, it curves. Now roll a smaller marble, the Earth nearby.
It rolls into the dip.
Right. It doesn't roll towards the bowling ball because of some invisible force. It rolls towards it because it's simply following the curve in the sheet, the curve in space-time, created by the bowling ball's mass. Gravity is the curvature of...
That is just fundamentally different.
Completely game. And the theory predicted all sorts of bizarre, counterintuitive, like gravitational waves, ripples in space-time itself, caused by massive accelerating objects like colliding black holes.
Which he predicted back then.
Hypothesized in but they were so faint, so hard to detect, they weren't actually confirmed by direct observation until a century later in 20...
Incredible foresight.
Yeah. And his work was also pioneering the theoretical understanding that would eventually lead to the concept of black hole. And there's also that interesting little sidebar about the discovery itself.
With Hilbert.
Yeah, the German mathematician David Hilbert. They were working in parallel, corresponding, influencing each other, and they arrived at basically the same final equations for general relative field equation, almost simultaneously, within days of each other in late 19...
Darwin and Wallace with Evan.
Exactly. It shows the ideas were kind of in the air, the time was ripe for this massive theoretical leap, and these these two brilliant minds both got there pretty much.
So the scientific world must have been buzzing. But how did it get confirmed? How did the public find out?
The big confirmation came in 1919, thanks to an English astronomer, Sir Arthur Eddington.
What did Eddington?
He led expeditions to observe a total solar eclipse. The key was to measure the exact positions of stars that appeared very close to the edge of the sun during because their light would have to travel right past the sun's massive gravitational field to Earth. Now, according to Newton, gravity should bend light a tiny bit, but according to Einstein's general relativity, where gravity is space-time curvature,
the light should bend more because it's following that curve.
Exactly. It should bend twice as much as Newton.
And Eddington's measurement.
They confirmed Einstein's prediction. Stunningly accurate. The results were announced globally. Newspapers ran headlines saying Einstein had overthrown Isaac Newton's model of Earth, which had stood 200.
Wow, that must have been the moment he went from being a famous scientist to basically a global superstar.
That was absolutely the turning point. He became an international phenomenon overnight. Interestingly, though, when he finally got the Nobel Prize in Physics in 1921.
It wasn't for general relativity. That seems crazy.
No, it wasn't. The committee specifically cited his 1905 paper on the discovery of the law of the photoelectric. General relativity was still seen as maybe too theoretical, too controversial by some at that time.
But the Nobel and the fame led to lots of travel.
Oh, yeah. Global tours with his second wife, Elsa. They went everywhere. New York City, huge reception, met the mayor, prominent Jewish community leaders, met President Harding in the U.S., then voyages to Japan, Singapore, India, and a really key visit to Palestine, which was significant for his later connection to Zion. He was suddenly the world's most recognizable intellect, a kind of scientific rock star.
So the 1920s, fame and accolades, but also intellectual battles.
Big time. The most famous was his intense, very public debate with the Danish physicist Niels Bohr.
Bohr, another giant of physics. What were they arguing about?
The fundamental meaning of quantum. Bohr had won the Nobel in 1922 himself. And remember Einstein's 1905 paper on photons, the light quanta? Bohr actually refused to believe in photons until about 1995.
Really?
Yeah. But the deeper debate wasn't just about photons. It was about the weirdness of quantum mechanics, inherent probability, its uncertainty. Einstein just couldn't accept that the universe at its fundamental level was based on chance.
That's when he said his famous line.
God does not play dice with the universe. He felt there had to be some deeper deterministic reality underneath the problem.
And Bohr's response.
Equally famous. Einstein, stop telling God what to do.
Their arguments were legendary.
Yeah.
It really came to a head at the famous 1927 Fifth Solvay Conference in Brussels.
And that conference was stacked with brainpower, right?
Unbelievably stacked. The sources point out, of the 29 scientists attending Solvay that year, 17 of them either already had or would later win Nobel Prizes.
Wow. Who else? Oh, Marie Curie, Werner Heisenberg, Erwin Schrödinger. Basically, everyone who was anyone in the quantum revolution. And right at the heart of it were Einstein and Bohr just battling over the nature of reality.
Amazing. Yet even this icon, this genius, he made mistakes. Big ones.
Oh, yes. He was human. And he later openly admitted what he considered his biggest blunder.
Which was?
It relates back to general relativity, actually. Around 1917, when he first tried applying his equations to the entire universe.
Okay.
The equations themselves naturally suggested that the universe couldn't be static. It had to be either expanding or contracting.
But the view at the time was different.
Yeah, the prevailing astronomical consensus back then was that the universe was static, stable, unchanging overall. This clashed really badly with Einstein.
So what did he do?
Kind of fudged it. To make his beautiful equations match the accepted static model, he arbitrarily inserted an extra term into the math, a sort of cosmic repulse called the cosmological constant.
Just to make it balance out and stay still.
Pretty much. He forced his physics to fit the consensus. Even though the math itself was pointing towards something more dynamic, he just couldn't quite believe the universe wasn't static.
And then along came Hubble.
Exactly, Edwin Hubble. In 1929, Hubble presented his observations, Hubble's law, showing that galaxies are flying away from us, and the farther away they are, the faster they're receding.
Leading.
Meaning the universe wasn't static, it was definitely expanding, and expanding rapidly.
How did Einstein react?
He met with Hubble in 1931, saw the evidence, and it was overwhelming. He had to abandon his cosmological concept. He later famously said that introducing it, trying to force a static universe, was his biggest blunder.
Wow, to admit that publicly.
It says a lot about his intellectual honesty, doesn't it? Here's this monumental figure basically admitting to the world, I resisted the evidence for years because the idea of an expanding universe just seemed too huge, too radical. My mistake was being too cautious.
That's powerful. And this period of him correcting his own science, it coincides with absolute political disaster in Germany.
Tragically, yes. The Wall Street crash in 1929, The Great Depression, it fueled desperation. Millions turned towards the not their ransom. Hitler becomes chancellor in early...
Where was Einstein?
Luckily for him, he was already in the U.S. He was on a visiting fellowship at Caltech in California. Given his Jewish heritage and his very public pacifist and internationalist view, he was an immediate high-profile target.
They went after him.
Oh, yeah. They'd already searched his apartment in Berlin twice, raided it. He realized with Hitler in power, he simply not go back. It was...
So what did he do? Renounce his citizenship again?
He did. On his way back towards Europe, stopped in Antwerp, Belgium, went to the German consulate there, physically handed over his German passport, and formally renounced second time in his life.
An exile again.
But
Forced exile, yes. He eventually found a permanent academic home. He settled at the brand new Institute for Advanced Study in Princeton, New Jersey, and that's where he'd remain for the rest of his career, his longest affiliation. Did his research continue in Princeton?
Oh, yes. He kept working, often on very theoretical, almost speculative ideas. In the mid to late 30s, he collaborated with a young physicist named Nathan Rose.
And they came up with?
The theoretical model of what they called an Einstein-Rose, basically a kind of tunnel or shortcut through space-time connecting two distant points.
The wormhole.
Exactly. That's what we call it now. It became an absolute staple of science fiction, the wormhole concept. But it came from their theoretical work on general relativity.
And his celebrity status continued in America.
So he connected with other prominent figures, especially fellow pacifists like the writer Claire and famously Charlie Chaplin. Yeah, there's this great story, the sources mention it, of Einstein attending the premiere of Chaplin's film City Light. And apparently the crowds cheered Einstein with the same kind of adoration they'd give a huge Hollywood movie star.
That's amazing. Science meeting Hollywood.
He had this unique blend of profound scientific achievement and genuine global popular fame. Just unmatched, really.
Okay, let's move into the final and maybe the most difficult chapter, the war years and the atomic bomb.
Yeah, this is where his pacifism faced its old test. By early 1939, physicists in Europe, particularly in Germany, had discovered nuclear fission using uranium.
Meaning a bomb was possible.
The theoretical possibility of an incredibly powerful bomb based on fish suddenly terrifying field. And this presented just an agonizing paradox for Einstein.
Because the Nazis might get it first.
Exactly. That was the fear. A group of brilliant Hungarian emigre physicists in the U.S., Leo Szilard, Edward Teller, Eugene Wigner, they realized the danger. They knew that the scientists back in Germany, people who had been Einstein's colleagues,
they could be working on this.
They could be. And if the Nazis developed an atomic weapon first, the consequences were unthinkable. So these Hungarian scientists, they knew they needed to warn the U.S. government at the highest level.
And they needed Einstein's influence.
They needed his name, his credibility. He was the most famous scientist in the world. So they drafted a detailed letter to President Franklin D. Roosevelt explaining the potential for an atomic bomb and warning about the German effort.
And Einstein signed it.
Yeah.
Despite being a pacifist.
He did. It must have been incredibly difficult for him. But the fear of Hitler getting the bomb first outweighed his aversion to military involvement. This letter, Einstein-Szilard letter of August 1939, is the key document that really kicked off the U.S. effort.
The Manhattan Project.
The Manhattan Project. But it's really, really crucial to stress this. Einstein's role was limited to signing that initial warning letter.
He wasn't involved in actually building the bomb.
No. He viewed war as a disease. He wasn't part of the Manhattan Project team, which was led by J. Robert Oppenheimer. He wasn't involved in the physics or engineering of the bomb itself. The profound irony, of course, is that the scientific basis for the bomb stopped from 1905.
Right, his energy mass equivalence.
But he was politically and morally excluded from its action.
So when the U.S. dropped the atomic bombs on Hiroshima and Nagasaki in August 1945, how did he react?
With absolute horror and deep self-reproach. He was just appalled by the scale of the destruction, the human cost. He declared publicly, "The time has come now when man must give up war. It is no longer rational to solve international problems by resorting to war." And in the years that followed, he repeatedly expressed profound regret that his 1905 research, his discovery of mass energy equivalent, had inadvertently contributed to the development of such devastating weapons.
That must have weighed heavily. Did he continue scientific work in his final years?
He did, though his main focus shifted towards a kind of ultimate scientific quest, the unified field theory.
What was that?
It was his attempt, his final major work, published around 1950, to find a single, elegant mathematical framework that could unite all the fundamental forces of nature known at the time, gravity, electromagnetism, and connect them with the geometry of space-time from general.
A theory of everything.
Essentially, yes, a single theory explaining all physical laws. He didn't succeed, finding that unified theory remains the holy grail of physics even today. But his attempts, his mathematical explorations, were still really important for advancing certain areas like differential geometry.
And he remained politically active?
Very much so. His core beliefs didn't change. Lifelong aversion to violence violence, he openly admired Gandhi. He became a strong critic of nationalism and unregulated capital. He actually advocated for some form of world government to end the competition and conflicts between nations.
That must have attracted attention during the Cold War.
Oh, absolutely. His socialist leanings, his calls for internationalism, they didn't sit well with everyone in post-war America. The FBI under J. Edgar Hoover was deeply suspicious.
They kept a file.
A huge file. By the time he died, the FBI dossier on Einstein reportedly ran to over 1,400. They tracked his speeches, his associations. They were definitely watching.
Wow. And what about his Jewish heritage in these later years? You mentioned the visit to Palestine earlier.
Yes, that connection remained important, especially after the Holocaust solidified his sense of belonging with the Jewish people. Even though he was personally agnostic, he viewed the Bible as primitive legends, I think.
But he supported Zionism.
He did. He'd served on the board of governors of the Hebrew University of Jerusalem since way back in 1925. And then, after Israel was established, a truly remarkable thing happened in 1952.
What was that?
He was formally offered the position of president of Israel, second president.
Seriously, President Einstein.
Seriously. It was largely a ceremonial role, but still, he graciously declined the offer. He cited his age, he was in his 70s, and also said he just lacked the aptitude and experience for dealing with people in that kind of official diplomatic capacity.
Humble to the end. How did his life end?
His death in 1955 seems very characteristic, philosophically calm. He'd been suffering from an abdominal aortic aneurysm, basically a bulge in the main artery in his abdomen. It ruptured.
A medical emergency.
Yes. He was offered emergency surgery, but he refused it. He reportedly said something like, "I want to go when I want. It is tasteless to prolong life artificially." He felt it was best to meet death with dignity when one's time had come.
And he died soon after.
The next day, April 18th, 1955, he was 76 years old.
And even in death, there was controversy about his brain.
Yeah, a rather ghoulish episode. The pathologist who performed the autopsy, a Dr. Thomas Harvey, removed Einstein's brain, apparently without explicit permission from the family beforehand.
Why?
Harvey claimed he wanted to study it, to see if it held clues to Einstein's genius. He kept it for decades. Later studies done on preserved sections suggested some potential anomalies, like maybe an unusual concentration of glial cells, which support neurons in certain areas associated with mathematical and spatial reasoning. But it's still pretty debatable.
So the icon status is just undeniable. His work changed human thought maybe more than anyone since Darwin.
You could definitely argue that. And the sources point out his main output wasn't even books, really. It was nearly 300 academic papers, though he did write over a dozen books trying to make his revolutionary ideas understandable for a general audience. He cared about communication.
And despite all that fame, that impact, he seemed to stay grounded.
He really seemed to maintain this profound sense of modesty rooted way back in that early self-driven curiosity. He famously said, "I have no special talents. I am only passionately curious."
That curious.
And that curiosity, born in that turbulent childhood, nurtured in the quiet of a Swiss patent office, it ended up completely redefining the physical world for all of us.
So we've traced this incredible journey from that philosophical teenager reading Kant, forced into being stateless, to the patent clerk who just upends physics in 1 year.
The annus mirabilis.
And then becomes this global icon who has to wrestle with the terrifying moral consequences of his own discoveries. His name means genius, yet the story is so much about unconventional paths, struggle, and that absolute willingness to challenge accepted ideas.
And that brings us back to that moment of humility, his biggest blunder.
Right. Calling the static universe theory his biggest mistake.
Yeah. A theory he clung to, remember, partly because it fit the consensus. He resisted the evidence for an expanding universe because the idea just felt too big, too radical at the time. His greatest error, by his own admission, was being intellectually cautious when the universe was telling him something.
So here's the final thought for you, our listener, to maybe mull over. Einstein, the ultimate visionary, made his biggest admitted mistake by resisting evidence because the implications were just too vast. What scientific consensus or maybe deeply ingrained assumption that we hold today? What might be our generation's biggest blunder? What evidence might we be collectively resisting, maybe just out of comfort or caution, because accepting its implications feels too expansive, too radical, or just too vast for us to really comprehend?
Something to think about as you navigate your way world, a world shaped in part by his remarkable till our next